Okay, have a look with me. These points here, right, coming back to this circle, the unit circle, you can define them, right, using the coordinates here, cos theta, sine theta. And this is a parametric definition. It relies on knowing what theta is, okay? Now, so far, all 6 of the equations that I've got for defining this motion, right, they're all in terms of a parameter. It's not theta though, it's time, right? So there's time sort of built into this diagram here, right? Now, to go from here to here, right, I would say, look, I don't need to worry about a parametric definition of this shape. It's a very simple shape that I know. It's a circle, right? So I could define it in a Cartesian way like this. X squared plus y squared equals 1. That's a definition without the parameters, okay? The equation of path is exactly the same idea, right? It says, look, I know what this shape is and I don't need to worry about the parameter time. I can just say, that's a parabola. And I know what kind of a parabola it is as well. How are you going to go about doing it? You've got 2 alternatives. Number 1, you can say, well, look, I'm at 0, 0, right? And what is the coordinate over here? We've worked it out in the process of the question. What is it? It's 2, 0, isn't it? Didn't we say that Adam was 2 meters away from Steve? That's what we concluded, right? So you can do that, and then you need one more point to define a parabola, because there's an infinite number of parabolas that goes through those 2 points. What might be a good idea to choose? Probably this guy up here, right? Which would be, by my reckoning, that'll be 1. And how far up did we go? Also 1, right? So you can use those 3 points and you can define a parabola. Easy, okay? But that's partly because the coordinates are easy. Usually you don't get away so lucky, okay? So in a situation like this, how would I go from here to here? How do I get rid of a parameter? Yeah, you need to do something to do some substitution, right? In this case, you would square and you'd use the Pythagorean identity, okay? We're going to do something similar here, but we're going to take our x equation and our y equation. Minus 5t squared plus 2 root 5t, I think. Okay, that's what we're going to do. So I want to get rid of the parameter, I want to get rid of all the t's, right? So probably the best way to fit this is x into y, because the y equation's a bit of a mess, right? So I say t equals x on root 5. A sense? Yes? Okay, I get it just from the horizontal displacement. So now I can take all of the t's here and replace them. Minus 5, there's t, squared, right? Plus 2 root 5 times, and there's t again. Yep. Okay. Square root of 5 squared, 5. 5's cancel, minus x squared, right? Root 5's cancel, plus 2x. That looks about right, doesn't it? Okay. Like I said, of course you end up with a simple equation because they were simple numbers, right? But sometimes this mess here ends up pretty awful, right? I think you probably got introduced to the minus v, g, cos alpha, blah, 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 right? All of that, right, is kind of a shortcut way of arriving at this point. Can you see that the only reason we could do this is because we spent like 4 or 5 parts of the question developing what this is and developing what this is, so it takes time, okay? But you can go here directly if you know what all of these things are. Everything over here completely defines the situation. Okay.